Hello there. Today we are going to see about water jug problem, which is also part of state space diagram. Let me take out this is states water jug problem, state space diagram. Okay. Now let's move on. This is water jug problem known as water pouring problem or die-hard problem. It is a classic challenge for artificial intelligence, sorry, and computer science. Okay. The puzzle role are measuring the specific quantity of water using multiple jugs. It is merely a brain teaser. Its fundamental problem frequently employed to various problem solving strategies of algorithm, notable search and optimize techniques. The goal is to fill one jug of water without exceeding the capacity and transferring water from one jug to another. So we have got the goal is to fill both the jug of water or one jug of water without exceeding the capacity and taking water from other jug. This problem can be solved with state space algorithm. As I've already said, it's a state space diagram. Now I've got two jug. Let me deal with two jug. There is no marking on it as I mentioned it. There is no marking given to it. No marking. One jug is a 4 liter and other one is 3 liters. Okay, so let's take an example. I have drawn a jug A with 4 liter, drawn B. What is the solution? I have to get it 4. One jug 4. This should be 4 with 4 liters and this should be 4 with 2 liters. Initial stage we have got 0 0 bits, both are empty, and x is equal to 0, y is equal to 0, both are empty. X is equal to 0, y is equal to 3. This is fill. Then the next step, whatever the water is filled here, and I have just taking out this one, that becomes 3 liters. Then y equal to 0, then x is equal to 3, y equal to 3. That's it. X is equal to, again I fill the water, fill. Now x is equal to 3, y equal to 3. Now the other one, I'll take one water from here. X is equal to 4, x is equal to 4. I'll liter 1 liter from here. That becomes 1 liter from here. That is x is equal to 3, y equal to 3, y equal to 2. So x is equal to 4 and y equal to 2. This is a simple way which you solve it. And as it says it, you can transfer water from one jug to other. There is specific amount of water from without exceeding the capacity. So we haven't exceeded the capacity. What we have got two jug available to us with 4 liter and 3 liters, and we have filled without using any computer. But if I want to solve with the help of artificial intelligence, with the help of an agent, so how do you solve it? We have to make some rules, correct? We cannot directly tell that x is equal to 0, y is equal to 0. Initially is 0 0. So first we have put, let me go again through it. First we have put 3 liters here, then that's it. Then whatever the 3 liters is, we poured here. That x is equal to 3, y equal to 0. Now it becomes empty. Then again what I have got 3 liters of here. That's fine. Again, whatever the left out 3, I have taken 1 liter here. 3 plus 1, it becomes 4. So x is equal to 4, y equal to. This is the best solution I can able to give you without using any computers, but without using an artificial intelligence or agent. Now if I take an agent, how do you solve these problems? Now we have to make some rules. The rules are simple, which are giving which we design it based on this one. Now x is equal, x and y both are 0 0, that is empty. That is initial stage. We take it as initial stage and both are empty. First one, x and y. X is filled with a capacity of 4, y is empty. And other way rule is that x is equal to y, x is empty, y has filled, that is 3. Again I tell you, x capacity is 4, y capacity is 3. We have filled this one. This is first rule, we have made it. What is the second rule? X, y, x is equal to x 4. What is that? 0 4. Empty the 0 y, sorry, this is y. Empty the jar 0, whatever it is there, we are going to empty it, provided it should be greater than, provided there should be a water in that one, provided there should be a water in that one. X and y, y is equal to 0, provided y should be greater than 0. So this should be greater than 0. Condition satisfied. Then removing some water. How much water? X minus d. X minus d, whatever the water. Then x minus d into y. X should be greater than this one, and y minus d, provided y should be greater than 0. This is a sum part. So there are about 7 rules which we have made it till now. What are the rules? Initial stage is 0, then we fill one jar, then we empty the jar, then we remove the water from one jar. The next stage, rules continues. 8.1, x plus y. Whatever there in y we are pouring into x. Whatever there in y we are pouring to x. X plus y is greater than 4. Yes. Why? Because y is equal to 3 capacity, x is equal to 4 capacity. That is what. And y emptying and pouring water into this one, emptying and pouring water into other one. This is the part of it, correct? This is y equal to y, whatever there is when y plus 3, y plus x is equal to 3, because y capacity should not get more than 3. So these, whatever, combining both and filling one. This rule 8 and 9, combining the one and pouring them. Thus the next one is 8 and 10 and 11, which are very important for us. What? 4 minus how much you want to pour it, how much you want them to be in x. Provided if it is 3, then how much you want to take it? Only 1 liter. So let's take example. I have got 3 here, and I have got 3, and I have got 2 here. So 3 y minus 4 minus 3. What is y? 4 minus 1. What is it? 1. So if I take 1 here, what will become? 4. So how much you want to take it? This is what it is going to do it. Again, I'll tell you, x is equal to 3, y is equal to 2. So y minus 4 minus 3. Okay. 2 minus 1, that is 1 liter. 1 liter I am pouring into 1. This is pouring into x. That x becomes 4. So how much I want to take this one? And then the same way, taking some water, removing from others. This is for x, this is for y. So these are the some rules which we have made it. These are very important rules which we have to make it. For an example, again I'll tell you up. Initial stage, then we have filled the water, then empty jar, removing some water, then combining them and filling one, then removing how much water you want to it. Based on that rule, we have to design this one. Again, now we have got the solution. We have got 4 and 3. With the help of above rules, let's solve the problem. Initially 0, 0. If you remember it, this is 1. Initially 0, 0, 1. This is our rule number 1, which is available here. Correct? Yes. 0, 3. I filled only y. What is the rule number? It is 3. Correct? Which is already filled. Correct? Then whatever there I am filling in 3 in x. That is rule number 10. What is there in this one? I am filling that. How much you want to fill? It's depend. So let's move on. I make it 3. Then again I fill this one 3. Rule number 3. What is rule number 3? Again I am filling this only one quantity. What is that one quantity? Only y I am filling. I'm not bothered about what is the x here. That is what. Then I moved again. How much capacity I want? I can move it. You can move what? This one. These are the rules which are available to it. So based simply we cannot solve like this. Simply we cannot solve like this. We are pouring x is equal to 0, y is equal to 0. We cannot solve like this the problem. We have to make some rules. What are the rules we have to make? These are the rules we have to make it, and then we solve this problem. X is, which is the rule number 1. This is rule number 3. This is rule number 10. This is rule number 3. This is rule number 10. If we specify this, we can able to solve the problems. This is water jet problem, please. Hope you understand it. Thank you very much.